this is Dr. Sarfaraz from Sri Chaitanya Infinity Learn. So dear students, today I am going to teach you a very important confirmed topic for your mains and advanced examination, that is acidity and basicity of organic compounds. Now you know that acidity and basicity of organic compounds is very important because because a confirmed question always appears from it. So today I am going to teach you more than 50 different varieties of examples on acidity and basicity of organic compounds. ठीक है, अभी acidity organic compounds only we are seeing, we are not seeing inorganic compounds. That means HCl, HBr, H2SO4 we are not focusing much, but we are trying to focus on organic compounds containing carbon, right? Okay. So all of you do subscribe to our channel. This is a new channel and I think today is the inauguration day of the channel. It is the first day of the channel. Obviously on this channel you are going to get lots of more videos which are useful for your last moment preparation of your examination. So today I will complete acidity and basicity entirely, right? Okay. So let's begin the class. Okay. Now, right. So first we will see the most important topic, that is acidity of organic compounds, right? Acidity. So whenever acidity will come in mind, in stomach, that okay, and all that things will come in mind. Acidity, I got acidity, that is different. That we are referring to hydrochloric acid present in stomach, this is different. So what is the meaning of it? First we will see a clear basics of it without wasting time. So first I will teach you the basics of this acidity. Here any compound is given, any compound is available, and imagine it is able to give H plus ion. Any compound which is able to give H plus ion, then this compound is called as acid. Pack up. Generally in organic chemistry you feel, carboxylic acid or acid. No, it is not like that. Alkanes are also we can call as acid. Ammonia, though it is a base, we can call it acid. So what is the requirement and condition we are going to see? So any compound which is going to give H plus ion is called acid in organic. We are focusing organic point of view. And if that compound is giving H plus ion and that too fast, then it is called strong acid. And imagine it is a lazy fellow and giving slow H plus ion it is giving, then it is called weak acid. So what is the summary here or the first basic? If any organic compound able to give H plus, slow weak acid, fast strong acid, able to give H plus ion, then simply you can call it as acid. This is point number 1. Then the tendency or the ability. Now this is part 1, basics part 1. Now we have to go for the part 2. For part 2 we have to study what is the meaning of Ka. K is nothing but we also call it as ionization constant or dissociation constant. The general name we use is ionization constant. Okay, nothing is going to happen, right? Ka. What is Ka? I will explain you in a very local language, simple language. Ka means the, let me use non-chemistry word, in a non-chemistry word. Let us assume it is a time taken to give H plus ion, right? It is a time taken to give H plus ion. So if it is coming fast or slow, are you following? That fast coming out immediately, slow is coming a bit taking time. So remember, in simple language, Ka is the measure of acidity. Ka is measure of acidity. It is measure of acidity. And here we always write acidity is directly proportional to Ka value, right? Means what? Imagine there is a compound X and there is a compound Y. If I say Ka value of this is 11 and Ka value of this is 15, now tell me who is having larger Ka value? Y. Then according to the concept, K is directly proportional to acidity. right? So this is the relation. Another important factor also enters, and that is nothing but called what? Tell me, pKb. Everybody, you are good in mathematics, you know that Ka and pKb are negative log relation, okay? Therefore, pKa is inversely proportional to what? Acidity. That means if I say x and y are there, if I say pKa value is 11 and if I say here pKa value is 15. Now you see the interesting fact, because I am going to teach you many examples and this concept is going to come. Therefore, beforehand, by taking some easy example, let us assume it. Then who is having smaller value? This one. If the pKa is smaller, that means acidity will be larger. So in this case, x will be greater than y. So these numbers are hypothetical numbers, imaginary numbers, right? So I hope everybody got a fundamental idea what is organic acid. Let me summarize. Any compound able to give H plus ion, you can call acid. Fast giving, strong acid. Slow giving, weak acid. Not giving, not an acid, right? Then we measure the acidic strength by using Ka value. It is dissociation constant or ionization constant value. I have not completed this, let me write here, ionization constant here, right. So K is directly proportional to acidity, more K value, more acidity, more pKa value, less is the acidity. So this is the basic fundamental concept of acidity, right. Now we will move ahead, right. Now we will move ahead, 1 second, and we will go for some examples. Now we will see factors affecting acidity. What are the factors affecting acidity? Factors affecting acidity, right. Right? It is a very important, and I am not going to explain you in a confusion manner, in a very direct, straightforward manner. I am going to teach you, right. First factor is, oh, I think I don't have rubber, okay, right. Right. The first factor is electron, oh well, later I will say electron density, right. The first factor is nature of R. Now R stands for surrounding group or neighboring atom, whatever, I will explain you, right. Now imagine I will take R, C double bond O, OH, and another case I will take R, C double bond O, OH, and here let R is equal to plus I group and here R equal to minus I group. Then what will happen, dear students? Here R will give electrons to carbon, plus I means you studied giving electron to carbon, carbon giving to oxygen and oxygen giving to hydrogen. Done. Now in second case you can see R is minus I, so it is pulling electrons from carbon and carbon is pulling from oxygen and oxygen is pulling electrons from hydrogen. So once oxygen will pull the electrons from hydrogen, it is something like a rope is there, tuck off and you are pulling one side, then what will happen? In which case the bond will break fast. So here you can see this bond breaks fast, this bond breaks. If this bond breaks, then this will happen fast, and already just I said if it is happening fast, it is called strong acid. So therefore this is strong acid. So without wasting time, we got one important point. What did we got? That, okay, one second, we'll summarize. What minus I effect, I'll summarize everything in one place also, is proportional to acidity. And already we acidity, and already we proposed acidity is proportional to what? K. That means K and minus I proportional to each other. Then plus I effect is, if plus I effect is more, then oxygen is giving to hydrogen. Imagine there is a row between you and me, we both are holding. Are you following? If I am pulling and you are pulling, the rope will break, that is bond will break. But imagine you are pulling and I am moving ahead, coming close to you like this, then the bond will not break. How does it breaks? Therefore, this bond, will it break easily? No, it is difficult to break. It is difficult to break. Therefore, this will be slow. So, therefore, plus I groups are like villains here, not good. So, plus I effect is inversely proportional to acidity. If plus I group is inversely proportional to acidity, then it will be inversely proportional to Ka, but it will be directly proportional to what? pKa. So, using this, now we are going to do some problems. So, first what I am doing, factor wise I am teaching you problem, then combination of factors I am going to teach a problem to you, right. So, now we are going to do problems based upon this particular trick. That means what? In cheap language, sir, you will say, Sarfaraz sir, one doubt is there, what is minus I effect, how shall we know minus I effect? Minus I groups, man, you studied, no. Minus I groups, you studied, no. Minus I groups like nitro, cyano, chloro, fluoro, bromo, iodo, carboxylic acid, acyl halide, etc. All these are minus I group. Plus I groups are nothing but alkyl groups like methyl. See, this is not the time to say you all these fundamentals, because you already should know this simple basics. But however, I have once again recollected to you, right. So, let me summarize the summaries. If you keep R plus I, then R will give to carbon, R will give to carbon, carbon to oxygen, oxygen to hydrogen. Then the bond is difficult to break. It is something like in tuck of 4 people are there. The last one is pushing for third one pushing second one pushing first one, the rope will not break. Okay. Okay, instead in the rope, you know, like loop thing will come, like that happens here. But here R, fourth one pulling third one pulling second one pulling first one, the bond breaks. Hence we summarized that more minus I effect, more minus I group, very nice. Acidity is, it's very good for acidity. So, in a very cheap and simple language you can remember, more minus I group good for acidity. Back up. Now, based upon this we are going to do some problems, right. Now, coming to some problems. So, first I am going to do some problems, all of y'all. I think I need to write. Solve this fast, very fast. So, first question I am giving all of y'all. Right. Now, this, let us say here I wrote nitro and this is methyl here. Come on. Solve this problem now. All of you, I will give you 5 seconds time, not more than 5 seconds. 1, 2, 3, 4 and this is 5. What is the order of acidity? Who is more acid? So, here you can see this is phenolic group, it is same. So, can we answer from there? No. Coming down, this is what group? Plus I group. What is this group? Minus I group. What is present here? Nothing is present here. Then we know that which group is very good for acidity? Minus I. So, without wasting time, let us say this is A, let us say this is B, let us say this is C. So, what is the order of acidity? Right? B greater than. Now, competition rises from plus I and nothing is there. So, nothing is better or plus I better? Tell me, plus I is bad, no? Bad for acidity, no? So, plus I is not at all better. So, it comes at last. Then left over is who between this? Your C is left over. This is the order of acidity, right? Now, I am going to teach you more tough problem. Okay. Suppose this came in your examination hall, right? This has come up in your examination hall. One second. This I'll take some eraser. Some small change I will do. Right. Now all of y'all, someone will ask you this hydrogen and this hydrogen. Come on, very tough problem. What is the order of acidity? Till you solve, I will draw another structure. Please, all of y'all. Till you draw. Did you got the answer? Come on. Among these two, which is more acidic? The answer is first one is more acidic than the second one. Why? Because here you see this is minus I, keto is minus I, here also minus I. But here at this point, you know, it's hydrogen only. Hydrogen is considered as a neutral group, correct? But here you can see one methyl group is present here. And this will be acting like what group? Plus I group. So from one side minus I, from here pulling and from here giving. From here pulling and from here no giving. So it is something like someone is slapping you and saying sorry. One side plus I and one side neutral. And this side only sorry is saying, but no one is slapping you. Okay. Hence from here slapping, here sorry, or here sorry, no slapping. So nothing but minus I and plus I are almost compensating each other, but here only minus I effect is there. So hence this compound is more acidic than that compound coming here. Come on, tell me. I will give you a hint. Focus this hydrogen and this hydrogen. You may fight with me, Sarfaraz sir, I am not agreeing with you. Okay, what is the problem? The problem, why you saw this hydrogen only, you can come to this hydrogen also no, this hydrogen also no, this hydrogen also no, here also you can come no. Why you went there only? My dear, we generally see alpha position. Always remember in examination hall, wherever you have minus I group, neighbor you only have to see, only neighbor. We don't see anything, okay? So whatever minus I group is there, are you following? To that you have a carbon, that is called alpha carbon. To that you have a hydrogen. We focus that much area only. We don't focus anything further. Okay. Or we can, but generally this is the basic fundamental. Alright. Now tell me A hydrogen and B hydrogen. Which is more acidic? In A and B, A is more acidic. I can explain you this by many things. One of the reason is here you have minus I and here you have minus I. Two minus I's, but here only one minus I. That is one reason. Another reason is if you remove, if that proton HI will go, then you are going to get a negative charge. And this negative charge can participate in resonance from two directions. One is this direction, right? And also it can participate in resonance in this direction. Got it? Right. Got it? So here you can see, that means dear students, we got a new idea, we got a new concept. What is that? Here we can add. Acha, tell me, what is this called? Conjugate base. So conjugate base is stable. Oh my goodness, a new technique came, a new trick came. If conjugate base is stable, then the compound will be more acidic. So please write down somewhere, your place is not there. So I will write somewhere. So here you can see, it is stabilized by two different resonating structures. Actually both are same. Are you following? And we know that identical resonating structures are more stable. That means this compound is very, very stabilized by the resonance effect. Okay? But this cannot. This cannot. You will say, no sir, you are saying wrong. This also can. Yes man, this can, but only one side. No. This can leave the proton and can stabilize only from one side. But this can stabilize from two sides. No. So this is having more resonance. No man. That is why. That is also okay. Okay. This is more better. Now we will go for some more examples. So please write down all of you all one statement. Write take one box and write one statement. If the resulting, see I can make PPT or I can just keep typed material, but when we are writing and learning and listening together, that will be a different effect. Okay. So if the resulting conjugate base is stable by resonance or mesomeric effect or by some effect, then the acid will be strong. This is very beautiful and very important trick to all of you all. Right? Now I will give you another example based upon this. Okay? Let me take one example. Oh, what happened? What happened to this man? It has gone somewhere, or oh sorry, page has changed, nothing will happen, page has changed. So please all of you all do, oh, right, what is happening, man? What is this? Sorry, just have a tea break till that time, just a moment. I took the pen, right, it's okay. So I have some problem from my side only. Now someone will ask you this problem, or I am only asking you this problem. COOH, COOH. This molecule, and at the end I am writing this molecule. COOH and COH. Both are not same. Remember, they are non-superimposable mirror images that we will discuss later stages. Non-superimposable mirror images we will discuss later stages. Okay, nice poem it is. Right. Come on. Which is more acidic? Let us call this as X. Let us call this as Y. Which is more acidic? Okay. So this you can solve by this one. Both are looking same. Here you cannot apply minus I. Here minus I it will fail. You can't apply this stories here. It will fail off here. Both are equally minus I. Then how? Then this formula will be useful. Then, my dear students, answer is, let us say, I will not say, I will say. Right. So another trick is, now you see the conjugate base. So it has become, let us say, COO minus. Now if you all will give me permission, can I write this compound like this, COHO, like this? Then you can see in middle, this can participate in a new concept called what? Tell me all of you all. Hydrogen bond. Hydrogen bond, right? But in this particular case, if you remove the proton, then this is COO minus and this is COOH. Both have gone somewhere. I think I should erase a little bit to make this look you, because you may get confused. Right. Tell me, can this negative charge participate in hydrogen bonding this with hydrogen? No, it's not possible. So here you can see hydrogen bond. Therefore, this has become what? Tell me, stable. If this is stable, then this will be strong acid. And this cannot stabilize itself by any factor. Therefore, this is weak acid. So I hope this is another new concept by which, or new trick by which you got it. So why don't we solve another tough problem and an exception case which looks very odd to your eyes, but it is different. So let us solve it practically rather speaking. Right. Now all of you all, this is a very important typical case, or you can even call exceptional case. It is a typical exceptional case. Come on. So the question is very simple. It looks like, array, what is this? I can solve in 1 second. Parachlorophenol and parafluorophenol. Right. Come on, within 3 seconds think which is more acidic. You will say, Sarfaraz sir, according to your explanation given to us here, minus I effect is directly proportional to acidity. Then if I apply this concept, this is successfully correct, but rare cases it goes exception, right? Then if I apply this, then hypothetically, let us say this is A and let us say this is B. this is greater than this hypothetically, but practically it is wrong. So, it's theoretically A greater than B. This is theoretically on paper. Why? Because you will say, sir, fluorine, full minus I, more electronegative, number 1 in periodic table. Okay, right, okay. But practically, let us focus, B is greater than A. This is practical. What sir, practical, theoretical, how shall we know? How shall you know? Learn more examples. If you learn more examples, you will get more idea. That is a simple answer. Okay? Like the way we are studying now, parachlorophenol, parafluorophenol. Tomorrow if anybody asks you, you can say it. That means you have to learn. That is the criteria. Now the reason. Sir, in exam what to do, sir? In exam obviously you have to tick for practical. Sir, now give me the reason. You may sit there and think you are saying wrong, sir. Okay, I will give you reason and explanation. So if I give explanation to you using fluorophenol, chloro, no need. Let us take it. So let us start the journey. Now we will go for reason. I think I will take a bit. Ghana. Right. Parafluorophenol. So now all of you all, let us start the journey. So that proton will come out, this bond will break, you are going to get this compound and a negative charge will form. Done? Till here any problem? No. Now let me take some time and write some resonating structures of it. Then let us see what is going to happen. Okay. See, I am writing skeleton first. That is my style of teaching, because you will also understand it a bit easily. Ready? Done. Now I am writing resonating structures of parafluorophenoxide ion. Then this negative charge will form a bond here and this bond will form a negative here. Done? Then this negative charge shifts here and this will shift here. Done? I think till here it was sufficient. I have unnecessarily drawn 2 more structures, but I will keep it. Why? I will say you the reason. I will take parafluorophenol. I will take for comparison. It is hard, my dear students. Okay, but it's very interesting. One second. Done. So here I have removed the proton, okay, it has become this particular ion resonance. Same thing here, remove the proton, okay, right, negative charge, resonance. Because see, if you make both equal, then only comparison can be done. No, one you are showing, one you are not showing on the board, no comparison, right? Then here negative charge, this you got. Now this negative charge, if you shift here you got a delocalized negative charge. Right. Now be ready all of you all. Now the movie starts. Okay. Now everybody can see on the board, this carbon is having 2p orbital. You will say, what is new in that, sir? I know. Right. You have electrons here. You will say, yes, sir. These electrons are also in which orbital? 2p orbital. Then think in deep. Both are in same shell as well as the subshells, right? Then what will happen? The electrons of carbon, these electrons of carbon and these electrons of fluorine, both will participate in what? Tell me. Common sense, they will participate in what? Repulsion. This is IIT advanced model of question. Mains also we can say, but advanced model. But here if you come, here it is, you can see the shell is here what? Carbon is 2p only, it will not change. But these electrons of chlorine are in which shell? Tell me all of you all, they are in 3p shell. So principal quantum number is different, subshell is p is same, but shell only different. It's like I am standing here, this is 6th floor now, above 7th floor, some person is standing on my head. Any attractions, repulsion? No. For anything to happen, both must come in same plane. No. Therefore, same shell, same plane. Therefore, here any repulsions? Here no repulsions. Correct? If no repulsions are there, then this will be what? Tell me? Stable. Comparatively, this will be unstable. Correct? Got it? I will repeat. The negative charge is presently on the with the 2p shell and fluorine also 2p. Your repulsions will start. When repulsions will start, the negative charge will try to go back to its original form. But here it is stable. Instead of going to original form, it can keep on delocalizing. Hence, it is stable. No repulsion. Repulsion, no repulsion. So repulsions, energy increases, stability decreases. So now if you come reverse, if it is unstable, then this will be what, dear? This will be weak acid. Correct? And that is what? Stable. Then this will be strong acid. Why? Because already I explained you just a second ago. What? What was the concept? If the resulting conjugate base is stable by anything, in general stable, it will be strong acid. Did I use this dialog? So it is stable. So this is strong acid. Hence, B is greater than A. No? Nice problem, no? Right. I am going to teach you more of this problem. Right? Now, right. I hope we will proceed further now to some more examples and some more factors. Okay. So, what did we seen? The first, the first factor is nature of R, right? This was the first factor with example. Then the second factor indirectly was resonance. Then hydrogen bonding also we saw indirectly along with the conjugate base stability, right? Okay. Now we will go for a next factor. How does it play a role in acidity? And that factor is nothing but called as steric factor. Steric factor. You can call steric factor, or you can call steric repulsions, or you can even call steric hindrance. Are you following? Or you can even call steric interactions, or you can even call steric cores. Many names are in the market, but the fundamental word is what? Steric. Got it? Right. Now, steric factor or steric repulsions or steric hindrance, how does it play a role in acidity? Let us see with one live example. So, let me take this. It is difficult to answer. Actually, it's almost looking very same. Let us call this as A, let us call this as B. Which is more acidic and why? So it's very difficult. If anybody can guess, it's very good. Okay, you can comment later also. Maybe this is afternoon time, almost most of them are sleeping. But later, whenever you see, do ask your doubts in the section. Okay. Which is more acidic? Any guesses? Right. The answer is the first compound is more acidic. Just a moment, please. Right. Can anybody can guess why did I tick the first compound is more acidic? Why not the second one? Okay. Here the factors come called steric cores. So here all of you can see, if I take what is this group? It's methyl, Correct? Everybody know, no? What is this group here? This is also what group? Methyl. So this group is nothing but what? Methyl group, everybody know. It is written as what? CH3, or some books write it as Me. So this is, the middle group is what? Please tell me all of you. The middle group is your nitro group. Correct? The middle group is what? Nitro group. And all of you can see 3 big groups came in same plane. Yes or no? They came in same plane. Plane is same. Once they come in same plane, then what will happen? 3 big groups. It's something like in one car, 3 fat men are sitting in one Maruti 800 car. Or you just imagine the situation. Oh my God, one fellow will push one this side and this side, it's very congested it becomes. Yes or no? As a result, someone must come out of the car. Like that only, 2 methyl groups, this will slap nitro from here, this will slap nitro from here. Both are slapping the nitro group from 2 sides. That means repulsions, right? Then as a result, nitro will get angry. Hey, what is this? And it will go out of the plane. Hence here what happened? Since same plane is there, then what happened to nitro? It will go out of plane. I will explain you this by taking one example. Don't take tension. Example, I will show you. Look here. This is benzene ring. Plain benzene ring. This is methyl and this is methyl. Imagine middle nitro group is there. Right? Now this methyl is pushing the nitro group and this methyl pushing the nitro group. As a result, the nitro group will go out of the plane. Are you following? It will go out of the plane, it will go. Then what will happen? Then this methyl and this methyl, or whatever it is, this nitro group methyls are in different plane. When they are in different plane, then will it have effect on the in the compound? No, it will not have effect. Okay. Once it goes out of the plane, right? I repeat, due to repulsions of methyl, NO2 group goes out of the plane. Therefore, NO2 has no role or effect on OH. Right? So that means we summarize that this nitro is not going to do anything to this OH, but it means here this nitro, it will act like minus I here or not? Yes. That means in A, it will act like minus I. Therefore, due to minus I effect, it is more acidic. Got it all of you all? So this is, so here you can see, this example have no issue, minus I directly we can say, but here though same minus I group is there, it is not acidic in nature because of the repulsions, and this repulsions is nothing but called as steric factor. So is steric factor good for acidity? No, it's bad. It's a villain. It's a villain. It is a negative for acidity. So I hope you got another factor that is nothing but acidity. So please copy this. I will go for our next factor with examples. Right. Now our next factor is resonance. Very easy it is, everybody know. So next factor is what? Resonance. We can even apply the concept of mesomeric effect here. Right. Now how does resonance play a role in the acidity of organic compounds? Let us take by one example. Let me take this acid, it is very commonly called, okay, I will take organic acids preferably. Got it? And here I will take alcohol. Both are same, but they differ in the carbonyl additional group, functional group changes. Now imagine hypothetically H plus is coming out and the remaining compound is left over is the carboxylate anion. carboxylate ion. And here imagine H plus ion is coming out, and here you got the alkoxide ion. This is called alkoxide ion. Okay, dear students. Now all of you can see, I have explaining you by taking a fundamental example. If you compare the anions, or my old concept if you apply, this can participate in what? Resonance. So this can participate in resonance. So this is stabilized. This is stabilized by what? Resonance. Since this is stabilized by resonance, and do you find any resonance here in alkoxide? No. This is unstable ion. If this is unstable ion and this is stabilized by resonance, then what is your conclusion? Your conclusion is this is stabilized by resonance means, right, this must be strong acid and this must be fast. Similarly, this is unstable means this is a weak acid and this step must be slow. So simple, in general we can say resonance or a mesomeric effect will not play a role before, but it will play a role after. You can anywhere you got confusion, you can even perform the dissociation and you can check the H plus ion and later also you can decide which is strong acid by this technique. Okay, dear students. Now I am going to teach you many examples, okay, based upon my experience. I hope you are ready. Right. Many examples we are going to see. Be ready. So what factor? We will summarize what we have seen. Right here. We have seen that minus I effect is very important for acidity or K value. Next, we saw more minus I, more K, more acidity, more hydrogen bonding or more resonance, more acidity, or conjugate base concept we can see. Exception case, we have proved that the stability of anion is also important. Steric course is a villain factor, okay, it's a bad factor. If steric course is more, repulsions will decrease, right? Now coming to practice problem, and whenever in examination you are unable to get the answer, what to do? Then in exam, whenever 2 compounds, 3 compounds, 4 compounds are given and we are not able to do, means remove the H plus ion and check the stability of anion, then you will get the answer. Okay, right. Now we will go for some more examples. Chalo. All of you all, please try to do this example. Orthochloro, parachloro, propane and cyclopropane, trifluoroacetic acid, trichloroacetic acid, formic acid, benzoic acid. Right. Okay. More examples we can see. Malic acid and we can, I'll take down here, fumaric acid, next we'll do many examples, but let us see some practice examples. Chalo, some practice problems, right? Now all of you can see that the first example which I have taken here is nothing but orthochlorobenzoic acid and parachlorobenzoic acid. So obviously you can see your ortho effect is there or even minus effect is there, so this is more acidic. In cyclopropane and simple propane, right? In cyclopropane and this propane, you can see this ring is nothing but a strain ring. Are you following? Are you following? This is not strain, and this will be generally due to this what is happening here, due to more strain, it will try to release the strain, decrease the strain, right? So here cyclopropane is more. Here trifluoroacetic acid and trichloro, so you can see fluorine is more electronegative, yes or no? Therefore fluorine is more here. You will say, Sarfaraz sir, some time ago you said para, that is only one exception, man. Only one exception, don't apply that everywhere. Everywhere general law you apply. More electronegativity, more the acidity. Next, formic and benzoic, formic is more. Why? This hydrogen is a neutral group. It do not donates nor withdraws. But here, since acid is minus I, this will be acting like plus I. So plus I is inversely proportional to acidity. Got it? Now this is very, very important example to all of you all. I am going to teach this in detail. Okay? This is nothing but we commonly call as malic acid, and this is commonly called fumaric acid. Acha, tell me one thing. Sometimes you know, whenever you eat apples, after biting, after for some time, brown formation will happen. Brown color. Have you observed that brown color is only due to malic acid? In apple, there is an acid called malic acid. Malic. In apple, there is an acid called malic acid. After losing water to the atmosphere, it will become malic acid is brown color. Leave it all the discussions. Now someone will ask you, are you following, that which one is more acidic? Then we will do it. I also don't know. You also don't know. Whenever you don't know what to do, remove the H plus and check. Okay. Okay. So if I remove the H plus ion from here, then I will get a negative charge here, and this is C. Can I write this double bond OH like this? Yes. Here if I remove the H plus ion, then what will happen? This is COOH and this is COO minus. In these two structures, tell me which one is more stabilized or more stable. So you can see in this this can participate in what bonding? It can participate in hydrogen bond or hydrogen bonding. Correct? But here no hydrogen bond. Therefore, which is more stable? Obviously this is more stable. If this is more stable, then in first step this is strong acid, and this will become weak acid. Clear? Right? So remember, so in general, so you will say, Sarfaraz sir, how shall we remember? Remember, dear students, that in examination hall always famous and known examples only will come. You people don't study, man. You will be just sleeping the whole 7-8 months, and last 2-3 months you will wake up. If you study or from day one, little, are you getting? Little, if you study, then what will happen? Something will come out. Are you following? No issue. I am there to help you here, but be always well prepared. Now this I am trying to solve this problem, very unique problem and in a very unique style by which examiner can give you. Here I have written pK value. pK is negative logarithm of K, that you better know, right? So here values are given. This is called O cresol, this is called M cresol, and this is called P cresol. Now everybody can see pKa value have given. If I given pKa value, that means already I defined pK is inversely proportional to acidity. So who is having smallest value among these three? Smallest value, it will have largest acidity, correct? That means metacresol will be more acidic Now orthocresol and paracresol are almost the same. They differ in second decimal, but however, this is smaller value and next come is your orthoisomer. That means MPO. So whenever cresols are there, you can remember MPO, meta, para and ortho. Got it? Right. Got it? Now dear students, I would like to discuss one more tough topic to you, which may come to you in assertion reasoning, or very tough problem will come in JEE Mains or Advanced, that will be discussed. So let me focus to you. Just I will take 5-10 seconds of relaxation air and then I will come. Okay. Shall I change? Right. Now dear students, actually I want to discuss, okay, I will do at the end, no, why no unnecessary disturbing you, and trick also I will give you, 2 beautiful tricks I will give you, okay. Now do these problems fast. Oh my goodness, pen is not working, this board pen, other pens are fine. Wow, right. Okay, nice, beautiful problem. Come on, if all these are tough problems, these are not LKG, UKG problems, man. These are tough problems. You have to scratch your brain a lot to solve this. It's not too easy, but I will give you, I'm teaching to you. Are you following? So you can see if I began with easy, then slowly I'm trying to focus tough topics. So all of you keep trying. Okay, shall I help you a little bit? Okay, I'm helping. Sir, Sarfaraz sir, now you are giving PK value in exam, how? Arey man, just now I said you that practice and keep ready. In exam, don't waste time. 5 seconds, solve it and go. If in exam this is coming, it will come, as such it will come. And all these are famous examples, right? Now, the PK of this is 9.45 approximately. The PK of this will be 9.15 approximately. And the PK of this will be approximately 9.9. Done? Right. Okay, some are doing, do it. I will just relax and I will give you some more examples till that time. Doing or not, you keep trying. I will give you the solutions. What happened to this man? Okay. Come on, are you ready for the show? This, right. These 5 problems we will solve, right? Last 2 are very tough, man. Last 2 are tough and you will be fooled easily in examination. Okay, this is a bit average. Now tell me, so if you see PK value, smallest is what? This compound, it is called resorcinol. So you know you are also getting indirectly some names of organic compounds also, and this is what? This is called quinol, and this is called catechol. Catechol. So here you can see PK is more, means acidity must be less, yes or no? Right. So who is having least value? This one. That means resorcinol. Where is place, man? No place. Shall I write here? Okay, I'll write R. Resorcinol is more than catechol is more than quinol. RC cola. RC cola, cool drink is coming, no? RC cola. So remember RC cola. R resorcinol, C catechol, Q for cola. right, Rc. Now, let us see this 3. This is very easy, pretty easy. After this, I am going to give you tips. So, this is what, tell me, carboxylic acid, it has resonance, internal resonance, yes or no? But here such it does not have. Therefore, in these two if you compare, this is more. Let us keep this aside to avoid confusion. Later we will talk on this, okay. Now, in this two if you see, this is here it is hanging. What is this man? Methyl. What is methyl? Plus I. Same point. Anything is there? No, where nothing is there, what is there? Hydrogen. So, plus I is there here? No plus I. So, this will be more acidic. Now, coming to this one. This compound is a very famous compound. It is called Meldrum. Meldrum acid. It is called what acid? Meldrum acid. Now, most of the people who are listening to me will get confused. Okay, we didn't heard, sir. Leave it off. In exam, no one will ask you some unique things, right? Now, which is more acidic, Meldrum's acid or this compound? So, everybody can see in Meldrum's acid, here you are having minus I group and here you are having minus I group. And what did I said you long ago? That you have to see alpha means immediate neighbor. So, here if you see this hydrogen in Meldrum's acid, then what will happen? Imagine this hydrogen, obviously you can directly say the answer, this is more acidic. This is one way. Another way is that if you remove that, what is going to happen? You will get a negative charge and this negative charge can participate resonance two side and it can stabilize. But here such stabilization factors you cannot see anywhere here. Therefore, Meldrum's acid is more stronger than the given compound. Okay, very typical case. Now coming to last one, everybody will do wrong and you will get angry. Sir, one time you are saying one thing, ban, exception case are very important. How much you practice it is very important to you, right? Now tell me in these two which is more? So all the students will say like this. Students will say, sir, CHF3 is more greater than CHCl3. And imagine students' parents will say this one. Imagine your parents are saying reverse. No, this is greater than. Obviously, who will be correct? You are correct or your parents are correct? Obviously, our parents will be correct. Now you are getting angry there. Okay, why, sir? I will give you example, explanation because I have to change the page. Okay, I will explain you. So be ready for this. Okay, right. I am changing within. You can pause the video later stages and you can watch it. So, right now this compound, see this video will be available to you afterwards also within half an hour. Then you can rewind and see. This is called fluoroform. Fluoroform. And this is called, my handwriting is not so beautiful. It's okay for explanation. Chloroform. What did I said? Who is more acidic? What is the order of acidity? Chloroform is more acidic than fluoroform. Why? Because I'll give you the reason. Already I said you, man, one trick. If you don't know, remove the proton and see. Pack up. Okay. So this is fluorine. Sarfaraz sir is teaching confusing. Okay, not confusing. More examples, more the clarity will come. And more the energy will come in your body and more the confidence will come. So imagine all of you all, you are removing the proton here. And here you are imagining removing the proton here. Oh, sorry, mistake by me. I am sorry, I have done mistake. Right, I am writing fluorine only. Right, chlorine. Now if you see, you will be happy and excited. Sir, this is good minus I. I am agreeing with you. Sir, compared to fluorine, this is average minus I. Okay, I am agreeing with you. Sir, Sarfaraz sir, this is fast. I am agreeing with you. Sir, this is slow. Temporary, I am agreeing with you. But if you come here, here you can see old story. This carbon is in which orbital? Again 2p. Correct? If you remember, where, dear students, where? Let us go back here. Carbon 2p, fluorine also 2p. Remember, same concept is applied here. Ditto concept is applied here. This carbon is in 2p and these electrons are also in what? 2p. Both will develop what? Repulsion. When both will develop repulsion, what will happen? Energy will increase. Then what will happen to stability? Stability will decrease. If stability will decrease, this will not be fast, this will become slow. Same concept you can see here, this is 2p, but the electrons of chlorine here are not in 2p, they are in 3p. So here you can see no repulsion, opposite you can go. No repulsions, when no repulsions, energy may be much no change, and therefore this will be stable. If this is stable, then the reaction will not be slow, it will become fast. Hence, remember, in fluoroform and chloroform, chloroform is more acidic. If you want, I can give you the values, real values, and you can check it. Okay. So please write down all of you all. If you see fluoroform and chloroform, if you see pKa values, okay, fluoroform is 28 and chloroform is 15.5. Okay, here I think it is contradicting, no? Okay. Next. 1 minute. I'll make a note here. Okay. Okay. This is valid. Okay. This is solvent dependent. Okay. Solvent dependent. Right. Some cases it may be reversed, where chloroform is more acidic than fluoroform. You will say, sir, how shall we know as a student? I will teach you within no time. Right. Now remember all of you all, the last and the final factor is, okay, solvent effect. Without teaching you stories, I will say you, here we are having ambiguity, correct? To solve this, solvent effect will give you clarity. Okay, look here. So remember all of you all, one rule is there, that rule you should know. That rule is anions are stabilized, anions are stabilized by aprotic solvents. What did I say? What is the rule? The anions are stabilized by aprotic solvents. Anions examples are what? Fluoride, chloride, bromide, carbanion. You can write here CF3 minus just now which you studied, CCl3 just now which you studied, Grignard reagent R negative, iodide ion, any negative charge ion, hydroxide ion, etc. Any anions are stabilized in aprotic solvents. What is aprotic solvents? Which do not have proton. Which proton? Like DMS, dimethyl sulfide, DMSO, dimethyl sulfoxide, THF, tetrahydrofuran, benzene. Sir, benzene hydrogen is there? No. My dear students, I will say you what is the difference between aprotic. Protic you understand first. What is protic solvent? Protic solvent means you will have OH bond or NH bond type or SH bond. These bonds will find in protic solvents. Like water, OH bond is there. Aniline, NH bond is there. Thioalcohol, SH bond is there. So wherever these bonds are there, they are called protic solvents. Wherever these bonds are not there, it is called aprotic solvent. So tell me, in benzene, hydrogen is connected to oxygen? No. Nitrogen? No. Sulfur? No. It is aprotic family. Right? DMS, DMSO, toluene, xylene. Are you following? No. Sorry, a small change. Protic solvents. Okay? 1 second. I'm just sorry. Oh. Right. Okay. No, solvents are correct only. Okay. But anions are stabilized by protic solvents. I'll give you the reason. Right? Like water, like methanol, like ethanol, like phenol, like aniline, etc. Now, this example to understand, you come here, you will get it. Now, all of you all imagine there is a beaker, correct? Inside the beaker, imagine fluoride ion is there. Another beaker also you take, imagine in this beaker fluoride ion is there. In this, all of you all take aprotic. Aprotic means what? Like benzene. Already I wrote a few seconds before. So, lots of benzene molecules are there, correct? Now, here you take protic. Protic means, let us say methanol is there, CH3OH, correct? Then, what can you see, dear students? You can see here this hydrogen will participate in, are you following, hydrogen bonding with the fluorine, correct? Because this hydrogen is partially positive charge. But here this is already electron rich, correct? And benzene is also electron rich. So, do you think it will undergo stability? No. So, whenever you take anions in aprotic, they will become unstable. And whenever they become unstable, they are more reactive. So, please make a note, it is very, very important for you, okay? So, here it became stable, so it is less reactive, right? So, dear students, any negative charge is stable and happy, enjoying, okay, enjoying partying in protic solvents. P for protic, P for partying, enjoying. If it is stable, it will nicely relax and sleep. Are you following? And reaction? No reaction. Lazy fellow it will become. That fluorine became lazy fellow there. But here, if you take aprotic solvent like DMS, DMSO, THF, benzene, toluene, ether, then they will not participate with anion. They will say, anion, you be happy, and then anion will search for food and it will become a hard worker and it becomes more reactive. That is the reason why earlier example, two possibilities are there, solvent dependent it becomes, right. Now, we will go for, and now I am going to show you one trick, some techniques, okay. Right. Now, dear students, please, all of you all take this example. Please solve this fast. Phenol, carboxylic acid, water, ethanol, ethine, ethene. Let me call this as A, B, C, D, E, F, and let me take here butane, G. I will ask you to solve the order of acidity. So, all of you all remember one general trick for your examination, that is carboxylic acids are always stronger than phenol, generalization, and phenol is more stronger than water. Water is more stronger than what? Alcohols. Alcohols are more stronger than what? Alkyne. Alkynes are more stronger than alkene. Alkene is more stronger than alkane. This, what is this order? This is the order of acidity. This is trick, dear students. If you apply this order, if you apply this trick, then what will happen? Who will come first? B will come first. Then phenol, where is phenol? A will come. Then water, water is C will come. Then alcohol, where is alcohol? D will come. Then alkyne, E will come. Then alkene, F will come, and alkane, G will come. Okay, this is also one of the way or one of the trick, but you have to remember this. Okay, this is applicable in general, but when an exception comes, you should be alert of it. Right. Now, I will give you another trick which will be helpful and useful for your exam. Over. Over? Right. Now, I am changing the page. Right. Now, another trick. Trick number 2. Trick number 2, remember all of you all, inorganic acids, if I take sulfinic acids, inorganic acids, if I take phosphates, if I take carboxylic acids, if I take phenol, if I take alcohol, if I take amino acid, all of you know amino acid now. If I take any amine, remember all of you all, in general if I speak, sulfinic acids will have, if I focus pK values, they will have negative values, means least pK value. When they have least pK value, then the acidity will be very high. And if you come to inorganic acids like HCl, HBr, something like this, if you focus, right, then their pK value will be somewhere around 2, phosphates around 3, and carboxylic acid 4 to 7, phenol around 10. Hey, this is around, man, don't think it is negative, this is around 10. Alcohols will be around 12, amino acids, this is 11, this is 12, and this will be around 15. So this also you can use it to solve problems. So suddenly someone will give you hydrochloric acid or acetic acid, someone will give you like this, HCl, acetic acid, right, and methanol. Are you getting? Who is more stronger? Difficult to answer, it's not so easy, yes or no? But if you know the family, HCl falls in which family? Inorganic acids family. Acetic acid falls in which family? This family. Alcohol, this falls in which family? Alcohol family. So you can arrange the order, okay, pK negative logarithm of K, you can solve it, right. Now dear students, we will solve 2-3 more very tough problems and we will enter into the next topic, that is nothing but basicity. Acidity little bit long topic compared to acidity, both are long, but okay, right, I am moving now ahead. Now be ready all of you all. Oh, what is this? Right. One second please. Let us say this is A, B, C, D, E, F, G, H. A tough problem for conclusion of acidity. Among this, what is the order of acidity? It looks very hard, man, structure is looking very hard, it is very local. You can solve by this trick or you can even solve by this trick, okay. Let us see it. Chalo. So who is the strongest acid among this all? Obviously carboxylic acid will win the race because neighboring you have minus I group also, right? So first will be B. So this is order of acidity. B will be greater than who? Phenol will come, this is A. See, there I wrote small letters and here I am writing capital, it's okay. It's not correct actually, but you can neglect my minor mistakes, okay. I hope you can do it so. Then, okay, this is out of the game, this is out of the game. Now coming to this side. Now you have to see C. One second, sorry, nothing, it's not wrong. Small addition I want to do, addition I want to do. I am not doing anything, okay. Don't get tensed and confused, right. C, E, H, D, F is there. So next, who is more acidic? I am saying C. You will fight with me, sir, gone mad or what? How C, sir? Minus I, not there. Plus I, not there. Resonance, not there. Wait. If you remove this, you know in physics you got LBD diagram. FBD diagram. Sorry, FBD diagram, free body diagram. Like that, if you remove this and draw a free body diagram, here you have a double bond. And left hand side, in benzene ring also one double bond is there, correct? Right? So this proton, if it loses, then what is going to happen, dear? Here you are going to get negative charge. Due to this negative charge formation, here you are having total how many electrons? 6 electrons. Following Huckel rule, so it is what compound? Aromatic compound, it is having resonance. So next, that is why C came. Nice, no? Nice question, no? Right. A over B over C. Now coming to E. Who is E? Alkane. F, alkane. They will come last. H, alkyne. D, D, competition in DG. In D and G, which is more acidic? I am saying G will be more acidic. Okay. And then comes D. Sir, why sir? Why sir? Why D? Sir, nitro strong group, sir. Strong minus I, sir. Yes, man. Nitro is strong minus I. I know you are, I am agreeing with you. But once if you found your forms a negative here, this can participate in resonance. This side also it can participate in this side also, and here you can see this is in conjugation with this one also. So therefore, if you draw FBD of G, free body diagram of G if you draw, right? This is G, this is G, correct? So if you draw a free body diagram of G, you can see that this negative can participate in resonance with this one and this can participate to long extents, hence G. Then D comes next. After this comes what? Who is in the game now? F is in the game, H in the game, E in the game. E and F both are alkane family. E and F both are in which family? Alkane family. Okay, alkane family means they will come last. But dear, my dear students, already I said you that in E strain is there. One of the example I showed you here. Here, alkanes are more acidic because of strain. Hence, H will come, then E will come, then last F will come. Sir, why H came first? Array, alkynes, no. Just now we studied no. Alkynes, then alkenes, then alkanes. Alkyne, alkene, alkanes. Right? I hope this is a very beautiful question. Okay, to summarize acidity. Very beautiful question. So you know, like in physics, how do you draw FBD? In chemistry also, if you should learn how to draw FBD. In my coming classes, I will show you more. Okay, by that you will get more knowledge, more clarity will come. Right. Now I am moving to my next topic. Nothing but, shall we solve? Anybody, can you please comment and tell me, shall we solve some more problems on acidity or go to basicity? Because my agenda was acidity and basicity both. Okay, so I will go for basicity now. Okay. Any comment? Right. Then we will go for our next topic. But can I give you homework? Please all of you comment in at the end of the class or after tomorrow, day after tomorrow also practice. What is the order of acidity? You please do it, please. I know that this is too tough, but try, no man. What's wrong in that? What's the problem? What's the problem to do it? I'll give you hints, don't take tension. A, B, C, D, E, F, G, H, I, J, and this is K. This is your homework. You should tell me the order of acidity. I'll help you. I'll give you idea. This carboxylic acid is ordinary carboxylic acid, no resonance. But this carboxylic acid is connected to aromatic ring. Be careful. What to do you think? This is alkyne, this is alkene, this is carboxylic acid and sulfonic acid. Sulfonic acid has more resonance. Think. This OH connected to ring is phenolic ring, and this OH connected to not ring is called alcoholic ring. And this hydrogen is connected to nitrogen, and this hydrogen C is connected to carbon. So using this hint, you try, and in comment box you put the answers. Tomorrow or day after tomorrow, I will enter into the comment box and I will give you the correct answer. Now we are entering to the next topic, basicity, basicity of amines. Actually, dear students, could you please mind that tomorrow we will continue basicity? Can you please? Because I will take 1 hour class on basicity. Maybe in acidity till now you got exhausted. I have to revise this and end up the class. Therefore, tomorrow I will go for basicity. This class I will continue. I think Thursday. I'm sorry, not today. Thursday. I will be taking classes to you Monday and Thursday, and I will try to give all the. And you know, if I say you one statement here, you will not believe it. In single class, I am going to teach 900 organic reactions in coming up class. Which is the date I cannot say, but very soon, okay? Because Ramzan festival has come, so maybe weekend I may be busy, but next week I am planning that class. So you will be notified and you will be informed. So keep subscribing the channel and you will be notified about my class. 900 organic reactions in single class I am going to teach. Please record and keep this as evidence in coming up days. So be ready for it. And from that 900, if 2-3 questions will not come in IIT JEE, I will stop teaching. This is my promise to every student who is listening to my class. Okay? So be prepared and be ready. Okay? So we will revise the class and then I will stop. I will go for basicity in my next class. I will continue this next class. So what did we learn today? We have to summarize. Right. So fast summary for latecomers or other students. I said that acidity means whoever can give proton. It is acid giving fast, strong acid giving slow, weak acid. Ka is a measure of acidity. It is directly proportional to acidity. And pK is negative logarithm of K. So it is inverse of acidity. Then I started factors. So I started factors along with examples. The first factor I took nature of R. If I said R is plus I and if R is minus I, the bond will break, and I said the relationship. More minus I, more acidity. It is more proportional to Ka. See, this is summary. Therefore, I am going fast. Don't expect from me slow because this is all over. Okay. Then I gave some examples to you. Okay. And I said how resonance will play a key role in the conjugate base factor and stabilizing the conjugate base. And I gave a beautiful rule to you. Beautiful trick or technique I gave to everybody who is listening to my class, that if the resulting conjugate base is stabilized, then the acid will be stronger. Means after the proton loss, hydrogen bonding is there here. After proton loss, nothing is there here. So this is getting stabilized. Therefore, it is strong acid. Like that, I made some general rules, right? Then I explained a very beautiful exception case where everybody will say this is the order, which is wrong, and I said reverse. I said the order is reverse. And I gave the proof of repulsions. Then steric factor, how the steric factor is throwing away the nitro group and playing the role. So steric factor is a villain here. Then resonance is a hero. Resonance stabilizing the carbanion, the anion, and it is becoming hero. And more resonance stabilization, more the acidity. Then I gave different varieties of explanations and exceptions, beautiful explanations. This is Meldrum's acid we have seen. Then we have gone for fluoroform, chloroform, and we said that this is partially correct, partially wrong. That depends upon what? Solvent. Then we gone and studied a very beautiful role that anions are always stabilized by protic solvents, and the reason we have seen. Then we have gone for trick number 1. This you have to remember for exam, for any general order. Then trick number 2, how to guess the pK. Someone will say, hey, what is the pK of phenol? pK of phenol, what I know. So you can do at least guesswork. Sarfaraz sir said nearby 10. Say some dummy number. 10.2, it will become correct. Nothing will happen. Got it? What is the pK of alcohol? pK of alcohol. pK I know, pK of alcohol. Don't know, Sarfaraz. Nearby 11. 11.5. Okay, it will go correct. So nearby range you can give. So this is the way how to give guessworks. Right. Then I have got for some tough examples. Right, and then I have given you homework. So dear students, this was the end of our today's class, but I request you that we are having a free master class. Okay, join the master class. In description you are having the link. Okay, I will be teaching you organic chemistry in shortcut tricks manner and detailed manner. Right, this is our Infinity Learn site. Please, this also you will find in the link description. Please check it and do share and subscribe to our channel. Have a nice day. Take care. Bye bye. मैं और 1 घंटा ले रहा था सर.